So welcome back. This is part 4 in our series on understanding 3D rendering, and we're going to be using C++ to develop some 3D renderers. This video, we're going to expand a bit more on 3D objects and what's required to describe a 3D object to your computer so it can render it. In the previous video, we talked about some of the basics, such as vertices and vertex locations. We talked about face data to describe to the computer what vertices to use to draw each face. And we also talked about normals, which are basically perpendicular vectors to each face to show which direction it's pointing, so you can make calculations on lighting and that kind of thing. Now, in this video, we're going to talk about what's called texturing and UV mapping. And this is a really big subject, but it's very, very important to make your objects look realistic and look nice when you render them. And in the previous video, when we talked about the contents of an OBJ file describing each object, each 3D object, we kind of glossed over some stuff that had to do with texturing and UV mapping. And in this video, we're going to start to discuss that and explain what actually are we talking about. Now, to do this, we're going to go to the absolutely wonderful and highly useful software we downloaded last time called Blender. And one of the reasons why is because it's going to help us understand these concepts visually. We can actually look at what we're talking about, and it will help us really understand what we're doing. So when we're developing a 3D renderer, we say, oh yeah, I know what that is, and I've seen it before, and that kind of thing. So here we are in Blender, and if you start up Blender, it should look a lot like this, although you will probably see a cube in the middle. So what are we talking about with texturing and UV mapping? Well, let's say I'm an artist, and I have this I want to make this brick wall. Okay, I want to make an object that I can render in my renderer that looks like this, like a brick wall. You can see it's basically a square, and it's got some brick on it, right? So how am I going to do that? Well, let's see. It looks, in terms of basic shape, it looks like a cube, a kind of stretched cube. So if you're going to build this, you might go into Add Mesh Cube, and you may already have this. If you just started up Blender, you've got what's called the default cube. And I've got a cube, and I'm getting there. It's got 6 faces, and it's got 8 vertices, I think. 1, 2, 3, 4, 5, 6, 7, yeah, 8 vertices and 6 faces. So we already know about that from the previous video. So how do I make it look more like this? Well, if you see these little, on the gizmo here, you see these squares. Let's take this yellow one, and what that does is that scales the object along that axis. Okay, along this, what's the y-axis. And then what we can do, we're getting there, we can move this up. And if I click on this Y up here in the top right on the gizmo, it will give us what's called an orthogonal view, and we'll talk about that later. But I can then scale on the red and scale on the blue and press my middle mouse button to rotate. By the way, I'm zooming by scrolling the mouse wheel, if you haven't already figured that out. So now I've got my brick wall. I'm done, right? Well, not really, because it's just a white brick wall and there's no bricks. So how am I going to make it have bricks on it? And this is a really huge subject in 3D art and rendering and making objects. So your first thought might be, well, I need like an image of some bricks. So how am I going to get an image of bricks? Well, unfortunately, in this internet age, people go on and search for brick images and download it. But ideally what you would do is you'd get your smartphone out and you'd go into town or somewhere and you'd find a brick wall and you'd take some photos. You'd take a bunch of photos of brick walls. And you would come home and download the photos so that you have a little bit of control on what the images look like. And you would come out with something like this, right? So now you've got a 2D image. Now this is just a representation of a JPEG or a bitmap or whatever is on your computer, the image that you downloaded or you took with your cell phone. So your thought might be, and it's a good thought, take this two-dimensional image and just apply it to this cube and you're done. And that's right. That's generally what you want to do. So how are you going to do that? Well, for this front face, you've got here on the front, this big face, you can just take this image and tell the computer, okay, place the image on this front face, but you're going to have to stretch it a bit, right? You're going to have to stretch it. No, I need this image. So you're going to have to stretch it to fit this front face. And the problem is the bricks might look a little bit stretched. And, you know, if you've got a cube that's like this, and you've got an image that you're going to have to stretch, it's going to look goofy, right? But, you know, for the time being, let's just say that we've got the image and we can just tell the computer, okay, stretch it on this face. Okay, so now what about this top face? How are you going to put this image on the top face? Well, if you just take that image and squish it, okay, here's your original image, you're going to tell the computer, okay, squish it so that it fits on that top face. But it looks terrible, right? It's all these squished bricks. And the same thing's going to happen with these sides and the bottom. So you can't just tell the computer to put this image on each face because it's going to be distorted unless you luck out and you get a face that's exactly the same dimensions as this image. So now what are you going to do? You're going to have to figure out some way to take this image and apply it to each face so that it looks reasonable. And that is what's called UV mapping. Now, why is it called UV mapping? Well, this cube is in 3D space, and it's defined by X, Y, and Z, vertex locations and positions. X, Y, and Z define things in 3D space. This image is in 2D space, okay? So you don't want to get confused. You know, if you're going to say that this image has X and Y coordinates, like the pixels of this image have X and Y coordinates, you don't want it confused with the X, Y, Z of the 3D space. So in the land of confusing 3D graphics terminology, you define this image as a UV coordinate system. So it's basically X and Y, but they call it UV just to make your life difficult. So the process of UV mapping is telling the computer for every U and V pixel coordinate on this image, I want that placed at a certain location on the 3D image. So you are mapping your image, your 2D image, to the 3D object coordinates. So that's all it is. It's a way of telling the computer, take this image, put it on this 3D object, and here's how you do it. Because the computer doesn't know. Computer can't guess. You know, the computer doesn't know that your image has all these bricks, and if you put it on this wide face here, that it's going to get squished. The computer doesn't know that. You have to tell it. So you have to say, well, okay, in this case, for this particular face, I only want, this section of the image to be placed on this narrow face. I only want like one brick or two bricks to appear on this face. But on this front face, I want the entire image, right? So that's called UV mapping. It's telling the computer what part of the image goes to what face in the 3D object. So now when it comes to building a 3D render, you're starting to see, hey, I'm going to need some data included in the object file for this object, this brick wall. I'm going to need some data that describes how to map an image from 2D to the 3D of this object. So, for example, if I export this brick wall with the image attached to it, and you're going to bring it into your renderer, there's got to be some information in that OBJ file which defines how to map this a 2D image to the 3D vertex and other locations in that OBJ file. So there's going to be more data that you're going to be looking for in your OBJ file. Okay, so now let's take a little bit closer look at exactly how we do the UV mapping and how that converts to data in your OBJ file and what it all means. So here's my brick wall, and what I've done is I have UV mapped it. In other words, I have defined where I want this 2D image, how I want it to appear on each face of the block wall or brick wall. Now I've got front, back, top, bottom, left and right side. So that's 6 faces. And for each face, I need to define to the computer what part of the image I want to appear on that face. And as we said in the front and back images, front and back faces, I could get away with having the entire object mapped to that face. And with the side, top, and bottoms, I only want a portion of the image to appear. So you have to tell the computer how much you want, where you want it, and everything else. And that's the process of UV mapping. Now, if you look over on the left-hand side, I'm in Blender, and I'm in the UV editing tab. And what I've done is I've gone through and UV mapped this brick wall, and here is the results. And again, this is one reason why I really think people should get involved and learn at least the basics of Blender. I'm not going to give you a tutorial on how to use Blender. There's a bunch on the web. Blender Guru is great for Blender tutorials. But you really need to learn this stuff, and Blender is a great way to visualize things and see actually what's going on. So I'm in the UV editing, and I've gone through, and for each face, I have mapped it to the image. Now, the process is called UV unwrapping. And the reason why it's called UV unwrapping is because you are unwrapping your 3D object, kind of exploding it into separate faces and applying each face to the image in a view like this, which shows the computer how to correspond each vertex to each pixel of the image. So no longer do you have a three-dimensional cube, you've exploded those into individual two-dimensional faces and applied them where you want to match up to how you want the image applied. So, for example, let me select this left-hand side face. And you can see here, I've got 6 faces. If I explode these 6 faces, I've got 6 faces with 4 vertices each. So I've basically got 24 vertices that I need to space, I need to move on this image to show the computer where to apply each vertex to the image. So you can see I've got a bunch of vertices. These yellow dots are vertices. and the white lines indicate the edges of the faces. So I've got 1, 2, 3, 4 faces. These are the top, bottom, left, and right faces. And I've got the front and back are mapped to this entire image. And these are, the front and back are on top of each other. That's why you don't see them separately. So you can see I've got 24 vertices, 6 faces mapped to this image. So for example, if I take the left-hand face, here it is mapped to the image. So what I can do is I can move that face, and if you look over here, you can see that now I'm telling the computer, no, I want this image to, this part of the image to map to this face. Now I want this part. And you can move it all over, and you can even expand it. And I'm saying, give me more of this image on this face, which makes it scrunch in because it's the same width. Okay, so I'm basically defining to the computer how to apply that image to each face. And I've got to do that for each of the 6 faces. All right? Now, if you don't believe me, let's take a look at this face, the upper left corner. And let's take a look at this. Here's the top of that face. Let's tweak it around a bit. And you can see, here's the top of that face, and you can see this part of the image. If you look over here, oh yeah, it's the exact same thing. So I have mapped this upper left vertex to this pixel in the image. And I've mapped this upper right vertex of this face to this pixel in the image. Okay? So that's all I'm doing. I'm exploding the object into individual faces, each face with multiple vertices, in this case 4 vertices. So now I've got 24 vertices, 6 faces, and I am telling the computer where each of those faces and the corresponding vertices lies per the image. Okay, so now I'm going to export this brick wall to an OBJ file like we did in the last video, and I'm going to look at what's actually in the OBJ file to see how all this data gets transferred into the OBJ, and now hopefully we can make a little bit better sense of it. So here's the results of my export. And what I've done is I've formatted this a little bit. I've added some spaces to segregate some stuff so it's a little bit easier to read, and I've added some notations. But as you can see, it's in our last video where we just did a basic plane, it's pretty much similar stuff. I've got first couple lines are just comments. This line defines that there is a separate material file associated with the OBJ file that has data on materials. And it includes a reference to the brick image that we are using on this object. And we'll talk about that a little bit later in a different video. But it's basically a material definition that needs to be included with this object, so it knows where to get the image from and how to apply it. Again, as the last time, we've got a object identified, and that's the name. Now here we've got, as we recall from last time, the vertex data starting with a V. And it's basically the X, Y, Z coordinates of each vertex. And we've got 1, 2, 3, 4, 5, 6, 7, 8 vertices, which makes sense because we've got a cube that has 8 vertices. Okay. Now, what I've done is I've also done this in metric so that we can, so it makes a little bit more sense. If you look here at our object, I've centered one vertex at the origin, 0, 0, 0, and you can see it's 3 meters by 2 meters. So it'll be a little bit clearer here in the OBJ file. And you can see the vertices are 1 at -3, which is this over here on the right, up 2 in the Y, and 0.2, so it's this vertex here, right? And then we can go down each one. Here's the origin vertex 0, 0, 0, which is this one right here. So basically we just got the 8 vertices. And here is this section called VT, which is texture coordinates that we're going to look in this video. And I've segregated them into texture coordinates for each face. I've got one for the right side face, the bottom face, the left side face, the top face, and the front and back. See, I've got 1, 2, 3, 4, 5, 6 faces. And these are the texture coordinates, and we'll talk about those in a bit. Here I've got the normals for each of the 6 faces. We talked about those before. Here's another material definition. Here's whether I've got smooth shading. We'll talk about that later. And here we've got the face definitions. Okay, and I've added some notation to tell you which face definition each one is. So I've got the right side, the bottom, left side, top, back, and front. All right. So if we look at the front face, as we recall from last time, it says it's using vertex 8, 4, 2, and 6. And if we scroll up, 2, 4, 6, and 8 define the front face. And it's 0, 0, 0, 0, which is the bottom left, the front face vertex at the origin. It's the one right here. Then we've got 0, 2, 0. Go 0, 2, 0, so it's this vertex. And then we've got -3 and 2. And then we've got -3 and whatever it is, -3 and 0. So you can see we've got the face definitions with the vertex, which vertex is associated with each face. Now notice the second value, which we kind of skimmed over in the last video. Vertex texture coordinate 21, 22, 23, and 24 define the front face. And that's these right here. Okay, so what is that saying? Well, that's saying map these UV coordinates of the image to the front face vertices. Okay, so 21, 22, 23, and 24 vertex texture coordinates get mapped to the front face. And as we can see, the front face is mapped to this full image. And the image dimensions are from 0 to 1. The UV values are 0, 0 up here and 1, 1 down here. So what it's saying is the front face, we've got 1, 1, 0, 1, 0, 0, and 1, 0. So that makes sense. It's saying the front face has these texture coordinates. So these vertices for the front face are mapped to these texture coordinates, all right? And the same thing with the back face. Since it's mapped identically on top, 1, 1, 0, 1, 0, 0, and 1, 0, okay? So these are the exact same mapping because the textures are right on top. The faces are right on top of them, so we map them together. And you can see the back face is vertices 3, 7, 5, and 1. Texture coordinates 17, 18, 19, and 20, which is 17, 18, 19, and 20. And that makes sense. So now let's look at the left side, okay? The left side image is, we selected this guy right here. Here's the left side image. And it appears here in the mapping. So let's see if it makes sense what we've got. So the left side, this shows vertices 5, 6, 7, and 8 go to the left side. All right. So 1, 2, 3, 4, 5, 6, 7, 8. All right. So vertices 0, 2.2, 0, 2, 0. And if you go through these vertex locations, you can see, yes, indeed, it's these vertices on the left side. So it then says the left side, the texture coordinates is 9, 10, 11, and 12. So left side is 0.2 and 0, 0.3 and 0, 0.3, 0.8, 0.2, 0.8. All right? So the y coordinates are 0.8, and you can see that makes sense because we're not going all the way up to 1. See, this is 1, and we're only 0.8 because this guy is not at the full length. All right? So the y or the v coordinates at 0.8 makes sense. And the x coordinates, I'm sorry, I'm on the left side. The x coordinates are 0.2 and 0.3. So here we are, 0.2 and 0.3. So that makes sense. So basically, this face definition says the left side is vertices 5, 6, 7, 8 with texture coordinates 9, 10, 11, 12. So it basically ties this face and the texture coordinates with the vertex, the vertices that make up the face and the vertex coordinates, okay? So it's all tied together to the computer, all right? So it's kind of confusing, but if you get down to understanding the numbers, and if you actually look through one, that's why it's really nice to have Blender, because you can make a very simple object and map it and go into the OBJ file, actually look at it in Notepad and see if you can figure out how they're getting mapped and that it makes a lot of sense, okay? So that's the basics of UV mapping and images applied to 3D objects. And I'm not sure if we're going to do more. I think we'll probably do some more on this, talking about materials, and in upcoming videos. So hope this helps. Take care and have a wonderful day.